Beneath the vast, desolate expanse of the Siberian tundra lies a hidden archive, an ancient time capsule frozen solid for millennia. This landscape, seemingly barren and still, holds extraordinary secrets preserved within its icy grasp. Scientists are now venturing into this extreme environment to unlock fragments of Earth's deep past. Their mission to retrieve air samples from an era predating human civilization, sealed off from the modern world. This isn't just any air. It's a breath from 20,000 years ago, offering an unparalleled window into ancient atmospheric conditions. The very ground beneath their feet, known as permafrost, acts as a colossal refrigerator, preserving history. Permafrost is ground that remains completely frozen for at least 2 consecutive years, often for thousands of years. It underlies a significant portion of the northern hemisphere, shaping vast landscapes from Siberia to Alaska. Within this frozen matrix, air bubbles, ancient plant matter, and even long-extinct animal remains are perfectly preserved. The depth of this frozen layer can extend hundreds of meters, representing epochs of geological time. Siberia, in particular, boasts some of the world's deepest and oldest permafrost formations. For thousands of years, this frozen ground has acted as an impenetrable barrier, locking away atmospheric gases. When snow falls and compacts into ice, tiny pockets of air become trapped within its structure. Each layer of ice, therefore, represents a precise snapshot of the atmosphere at the time it formed. The deeper the ice, the older the air, stretching back tens, even hundreds of thousands of years. Scientists meticulously extract these ice cores, which are essentially frozen columns of compressed snow and air. The process is arduous, requiring specialized equipment and resilience against brutal Arctic conditions. Temperatures can plummet to lethal lows, testing the limits of both human endurance and machinery. Yet the potential rewards for understanding Earth's past climate are immense, driving these expeditions forward. A single meter of excavated permafrost can contain air dating back 20,000 years or more. This ancient air is a pristine sample, untouched by industrial pollution or modern human activity. It whispers tales of a world vastly different from our own, a planet shaped by ice ages and dramatic climate shifts. The last glacial maximum, around 20,000 years ago, saw vast ice sheets covering much of North America and Eurasia. Sea levels were significantly lower, and the global climate was much colder and drier than today. The air trapped within the permafrost holds the exact composition of the atmosphere during that time. Scientists analyze these ancient air samples to determine levels of greenhouse gases like carbon dioxide and methane. They also study isotopic ratios, which can reveal past temperatures and even the sources of the gases. These findings are crucial for reconstructing paleoclimate and understanding natural climate cycles. Comparing ancient data with modern measurements allows researchers to identify human impact on the atmosphere. The insights gained from this ancient air are invaluable in predicting future climate scenarios. Expeditions to the Siberian Arctic are logistical marvels, requiring extensive planning and resources. Teams of international scientists brave isolation and extreme conditions for months at a time. Specialized drills designed to penetrate deep into frozen ground without contamination are essential tools. The drilling process must be precise, often using chilled fluids to prevent the permafrost from thawing prematurely. Each extracted core segment is carefully cataloged, photographed, and immediately stored in deep freezers. Maintaining the integrity of the sample is paramount to avoid any contamination from modern air. Back in specialized laboratories, the ice cores undergo a meticulous analysis process. Sections are cut, and the tiny air bubbles within the ice are carefully released and collected. This ancient breath, trapped for millennia, then flows into sophisticated sensors and spectrometers. Each element and compound tells a story about Earth's past climate, vegetation, and atmospheric chemistry. The discovery of such ancient air is not just a scientific curiosity, it's a vital piece of Earth's puzzle. It helps us understand the natural fluctuations of greenhouse gases long before human industrialization. By comparing these ancient levels with today's, we can quantify the unprecedented speed of current climate change. The air reveals that methane levels 20,000 years ago were significantly lower than they are now. This potent greenhouse gas is a major concern today, as its concentration continues to rise rapidly. Permafrost itself is a massive reservoir of methane, locked away in organic matter for millennia. As global temperatures rise, the permafrost begins to thaw, releasing these ancient gases. This thawing creates a dangerous feedback loop where warming releases gases that further accelerate warming. The Siberian landscape is already showing dramatic signs of this change, with sinkholes and thermokarst lakes forming. These new features provide pathways for ancient methane to escape into the modern atmosphere. Understanding the ancient air helps scientists model the potential scale of future methane emissions. The implications of these findings are profound, pointing to the urgency of addressing global warming. Every meter dug into the Siberian permafrost offers not just a glimpse of the past, but a warning for our future. The fragility of Earth's climate system is laid bare in these frozen archives. The research continues, pushing deeper into the permafrost, both physically and scientifically. New technologies are constantly being developed to improve extraction and analysis techniques. The international collaboration among scientists highlights the global nature of this challenge. From remote field camps to high-tech laboratories, a network of dedicated individuals works tirelessly. Their efforts provide humanity with critical data to navigate the complexities of a changing planet. The ancient air, once a silent witness, now speaks volumes about our shared environmental destiny. Every gas molecule released from the permafrost carries a story from the distant past. These stories help chart the ebb and flow of ice ages and interglacial periods over geological timescales. The climate of 20,000 years ago was characterized by vast sheets of ice extending across continents. The air then contained lower levels of greenhouse gases, reflecting a naturally cooler planet. This ancient baseline provides a critical reference point for assessing current atmospheric changes. The rate at which greenhouse gases have increased in recent centuries is unparalleled in geological records. This acceleration is directly linked to human activities, primarily the burning of fossil fuels. The methane trapped in permafrost is a powerful agent, far more potent than carbon dioxide in the short term. Its potential release from thawing permafrost represents a critical tipping point for Earth's climate. Scientists are racing against time to quantify this risk and develop mitigation strategies. Siberia's vast permafrost region covers millions of square kilometers, making it a critical area for study. The sheer volume of trapped gases, particularly methane, is staggering, representing an immense carbon bomb. Local communities in Siberia are already experiencing the dramatic effects of thawing permafrost. Infrastructure built on once stable frozen ground is now collapsing, disrupting lives and livelihoods. The release of ancient viruses and bacteria, also preserved in the permafrost, poses another potential threat. Scientists are monitoring these thawed areas closely for any signs of previously unknown diseases. The entire Arctic ecosystem is undergoing rapid transformation, from its flora to its fauna. Changes in temperature and permafrost stability impact everything from migration patterns to food sources. The ancient air from Siberia serves as a stark reminder of Earth's delicate balance. It urges us to heed the lessons of the past, to safeguard the future of our planet. The ongoing scientific endeavors in Siberia are more than just academic pursuits. They are a global effort to understand the consequences of our actions on Earth's longest-running systems. The data collected from these ancient air samples informs policy decisions and international climate agreements. It underscores the need for immediate and concerted efforts to reduce greenhouse gas emissions worldwide. The story of the Siberian permafrost is a microcosm of the larger climate narrative unfolding globally. It reminds us that the choices we make today will resonate for thousands of years into the future. The ancient breath from Siberia is a powerful messenger, bridging the gap between deep time and our present reality. It calls on us to listen, to learn, and to act with the wisdom gleaned from millennia of Earth's history. The frozen secrets of the Siberian desert are slowly yielding their truths, revealing a past that directly shapes our future. The question remains, will we heed its silent 20,000-year-old warning before it's too late?